In this question, it is given that water flows in a streamlined manner through a capillary tube of radius A. The pressure difference being P and the rate of flow is Q. If the radius is reduced to A by 2 and pressure is increased to 2P, then the rate of flow becomes. So we know that the equation for rate of flow of liquid through a tube, that is dq divided by dt, is directly proportional to r raised to 4 and directly proportional to delta p, and you can write as divided by 8 eta L. So our aim is to find out what happened to this rate of flow. So we can write this dq divided by dt is directly proportional to nothing but r raised to 4, and it is directly proportional to the value of delta p. Now in question it is given that pressure difference being P and the rate of flow of Q, if the radius is reduced to 1 by 2, so this R becomes 1 by 2 raised to 4 into, and the pressure is increased to 2P. So we can write this pressure is increased by 2 times. So we can write this is going to be 1 by 16 into 2. So we can write this is something like 1 divided by 8. So if the initial rate of flow is Q, now the rate of flow is going to be Q divided by 8.